All right, let's get started. So, Charlie, if you're listening, I hope you had a good rest and ready to tackle some challenging questions from the 4 chapters from last week, 9B, C, D, E, the new stuff. Okay, so the format of today's lesson will be a little bit different. So normally I'll give you guys some time to work through the questions first, but that's normally for the easier questions, right? Now today we're going through the harder ones, so I will go through every single question I want you guys to do. Okay. Well, let's see how we go, but I have a list of questions I plan to go through. So go through everything first, and you're not allowed to write anything. All right, you're not allowed to write anything while I'm giving the explanations. And then the idea is that afterwards, after I'm done with all of the explanations, you guys will have to redo the questions from the beginning. All right, so if you go through 20 questions, you have to start with question 1 first. You can't do question 20 first because I just went through that. The idea is that once I finish the explanation, it's been like an hour since you guys heard about question 1. Okay? And then when you go back to question 1, your brain has forgotten a little bit about it already. So if you struggle to figure out how to do it, you learn a lot from that experience. Okay? So you can ask any questions. You can pause me and ask any question or any clarification. It's just that you can't write anything down. Mm-hmm. All right, so just try to pure memorize the technique I'm going through, and if you don't fully understand it, you gotta ask me. I can pause and explain it again, but I will not give you guys time to write anything down. Okay, first question 4. So this is chapter 9B, question 4. This question 4 has a few somewhat similar questions. A, D, and F are somewhat similar, and the technique to do them is, for example, question D, right? When you anti-deriving square root of x, 2x plus x squared dx, you need to go to expand the bracket somehow. And the idea is to, when you see this one, that's just power half. When you times this into the bracket, you will be able to combine the powers of x. Mm-hmm. Right? So that's how you'll be able to anti-derive it. So if I times that in, that will be x power half, and then 2x plus x squared dx. Multiply that in, that means I'll add the 2 powers, and that will be, the antiderivative is still there. I haven't anti-derived it yet, right? So it's still there. So that now it will be 2x to the power 3.5 plus x to the power 5.5. Any question?
No.
No? Sarah, all good? Yeah, it's just fraction addition. And now when you do, when you anti-derive it, remember what's the rule?
Like the written rule?
Yeah, the general rule.
You plus the top and then it's r plus 1 on the bottom?
Not quite. So power add by 1 and then divide by new power. So yeah, you just phrase it wrongly, I think. Divide by new power. Okay, so we do that for each of these. See if you can follow. Add the power for the first term by 1 would be 5/2. Divide by that is times by 2/5. Alright, so I'm not going to write the intermediate steps just to make things a little bit faster. Does it make sense? Yeah? Divide by a fraction is times by the reciprocal. Right? And then this one, add 1 to it, would be 7/2. So that will be divide by that. So that's 2/7 times into x to the power 5/2 plus c. Alright? Then just simplify. Well, the first one, save a bit of time. That would just be 4/5 x to that power 3/2. And then 5/2, sorry, 5/2, and the other one would be 7/2. Yeah, what did I write 5/2? There you go. Okay. Mm-hmm. Yeah, easy.
Sure.
So this one is straightforward. The next one is not so straightforward. Question B. Now this question B is quite similar to question C. So B and C are similar in the sense that they are a fraction. But what you should notice is that how many terms are at the bottom? One term. With the variable only. When there are 2 terms, which in some of the questions later you'll see, if there are 2 terms it will be different, but if there's only 1 term at the bottom, that means you can split that up. You can split up the fraction. The idea is that if you have, let's say, a plus b over c, right, then you can split that into a over c plus b over c. Any question?
No.
No? So that's the general idea, and now to apply that to this question here, let's say question B. 3z power 4 plus 2z over z cubed dz. Alright, so I'll break that up. 3z power 4 over z cubed plus 2z over z cubed dz. Okay, so once I've broken that up, it's quite simple. It's just simplify the z, so 3z plus 2z power negative 2 dz. And then when you antiderive it, you add 1 to the power, divide by the new power, so 3 over 2z squared. And then add 1 to this power is negative 1, divide by that is minus 2z to the power minus 1 plus c. Okay, that's it. Alright, so this question is only difficult if you don't know this main technique here to split up the fraction. Okay, because if you don't know how to split up the fractions, you won't be able to simplify it into like a standard form. This is a standard form. You can just antiderive each term separately. Okay, so that's what you need to watch out for question 4. Next is question 7. Now, this question 7 is one of those that's like, you need to combine a bunch of concepts in order to do this one question here. That's why it's a complex familiar one. A curve y equals to fx for which the derivative, so in the next exam you guys will have both the original function and the derivative. So you need to know when to do derive, when to do antiderive. So watch out for notations very carefully. Okay? You see the dash, that's a derivative. And then that will be x minus that one plus k. K is a constant and it has a stationary point at 1, 4. How do we use this information to find k? Well, stationary point has, okay.
Antiderive.
Not quite. There are a few ways to interpret this one information. So stationary point at 1, 4. You can actually deduce 2 pieces of information from this one. The first one is that when x equals 1, y is
0. 4.
No, is 4, yes.
And then for derivative, it's equal 0.
Yes, when the second one, when x equals 1, then the derivative f dash of 1 would be equals to 0. Okay, so from one statement, you can form 2 pieces of information because each of them gives you one substitution, right? That's one substitution, and this is another substitution. You can find something else with the other one. So which one are we using here? The top one or the bottom one to find k? The bottom one, yes. F dash at 1 is equals to 0. So then you sub 0 into f dash x and 1 into every single x in here. Alright, so we'll get 0 equals to 1 minus 2 over square root 1 plus k. And solve that, you get k. So 0, so that'll be 2 over square root 1 is 2. 1 minus that is negative 1. So k equals 1. Okay, once you've got k, then my recommendation is rewrite the equation with the k value in it. So you don't always have to refer back to the original equation. So x minus 2 over square root x and then plus 1. Okay, and then they asked to find the value of fx when x equals 4. Right, which means we need to find fx. And in order to find fx, in the next exam, you will need to make sure to write this notation here. Fx is the antiderivative of this equation here. Okay, recognizing the antiderivative will most likely get you half a mark to 1 mark. Just writing that one line there. Okay, and then you have to work through it. That's when you get more marks. Sometimes for longer questions, they may not give marks for that step there. They might give marks only if you show it that you understand the concept and then you can antiderive correctly. Okay, so in some questions they will test you. They'll give you marks a little bit later. But it's always good to write that step there. So antiderive it, that'll be x squared over 2. And then this one, now to save a bit of time, I will work this one out on the side here. That'll be 2x to the power 1/2, right? So antiderive, you add 1 to the power, which is x to the power 3 on 2, divide by the new power 3 on 2, and then times it by 2. So that means that we'll times it by 2 over 3, right? So that will be plus, or more like minus 4 over 3, x to the power, oh sorry, this is negative 1/2, my bad. 2x to the power negative 1/2, so when add 1 to it would be 1/2, yeah. So times by 2 over 1, so that would be minus 4 x to the power 1/2. Okay? Plus 1 would be plus x, and then plus c. Alright, so that's the main equation, and remember how do we find c again? We'll need to use the other piece of information that we'll given earlier. When x equals 1, y equals 4. So f when x equals 1 is equals to 4, which means that 4 is equals to, substitute 1 in here, 1 squared over 2 minus 4 times 1 to the power 1/2, and then plus 1 plus c. Okay, so 4 equals to 1 over 2 minus 4 to the power anything is just 1. Sorry, 1 to the power anything is just 1, and 4 times that is 4 plus 1 plus c. Right? Bring everything to the left hand side. That would be 4 plus 4 minus 1 would be 7 minus 1/2 equals to c. So that would be 13 over 2 equals to c. So once we found the value, we need to rewrite the equation here. Fx equals to x squared over 2 minus 4x to the power 1/2 plus x, and then plus 13 over 2. All right. This is not the final answer, because remember what were we asked to do? We were asked to find the value of fx when x equals 4. So it's only an intermediate answer, but you can somewhat box it up if you want, just to, because sometimes these intermediate answers will get a mark from the examiner. Okay, it's like the criteria would read something like, the student can correctly anti-derive this equation. What mark? Okay, so even though it's not a final answer, 1, it helps the examiner. 2, it helps you locate where your function is. Okay, where your function is when you're like looking through your entire answer here. Alright, it's like how the k plus 1 here, you can also box it up. Okay, so yeah, fx, and then they ask to calculate f when x equals to 4, I believe. Yeah, when x equals to 4, so that will be f of 4. Okay, let's calculate this one. That'll just be 4 squared over 2 minus 4 times 4 to the power 1/2 plus 4 plus 13 over 2. So that will be 16 over 2. 4 to the power 1/2 is just square root 4. So that will be 2 times 4 is 8 plus 4 plus 13 over 2. Okay, so that would be 29 over 2. And then minus 4. So that's minus 8 over 2. That would be 21 over 2. So that's the answer. That's the final answer. Okay, any question?
No.
Hang on. Okay, so the answer in the textbook is not 21
What
over 2.
is it?
It's 4.
How?
It's 4. Where is the mistake? Let's see. Equation's correct. Let's double check. Equation is... Yep, equation is correct. And 2 over square root x is 2x power negative half. Add 1 to that is 1/2. Divide by 1/2 is times 2 over 1, which would be 4 square root x, or 4x to the power 1/2. Right? And the minus is a minus. Okay, so far so good. Plus x, so 1 becomes x becomes x squared over 2. All right, so far so good, I think. Any mistakes there?
I can't see any.
Can't see any. And f1 equals 4, so when x equals 1, so that would be 1 there, 1 there, 1 there. The answer is 4. Okay. All right. Bring the 4 over there, that would be 8, and then minus 1 is 7. And then the 1/2 is subtract. Can't see any mistake there?
Neither.
Right? So then this is the equation. Does it sound about right? You can actually test something. Let's test if, because when we derive this, we will get back the original, right? So 2, when you derive that, that would be 2x over 2, which is just x, which is about right. When you derive that one, that would be negative 4 times a half times x to the power negative half, which is 2 over square root x. Yep, that's definitely correct. And then this one will just be 1, which is the value of k. Let me check the value of k. Yeah, k is 1. And then now it's just a constant. Is the constant correct? So we've got f1 equals to 4, right? When x equals 1, the answer should be 4. Yeah, should be 4. So we've got 1 squared over 2 minus 4 times 1 plus 1 plus 13 over 2. So 1 over 2 plus 13 over 2. So this one would be 14 over 2. And then minus 4 plus 1 would be negative 3. So that's negative 6 over 2 plus 14 over 2 is 8 over 2, which is 4. Yeah, so up to this point, it's 100% correct. Don't see any issue with this. So let's see. That means that if I made a mistake, it must have been down here. Can you spot any mistakes here? From this line? Or this line? Or the final line? Any mistakes?
No.
No? You sure? Sarah? Do you see any mistakes in these 3 lines?
Don't know.
Did I substitute in 4 correctly into the first line here? Sorry?
Is it the power before?
Power, the power half? Yeah, it is 4 power half. What's 4 power half?
2.
2 times 4 is?
8.
Which is the one down here. So seems correct so far. And 4 squared over 2, 4 squared is?
8.
4 squared is 16.
Yeah, but then divided by 2 is 8. 8 take 8 is 0 plus
Yep.
4 plus 13 over 2 is 21 over 2.
Yeah. It's 21 over 2. Can't find any mistakes. So what's the conclusion? Textbook's probably wrong.
Oh, that's a bold call.
Bold call, but I have found a few mistakes in the textbook before. This is not the first time.
Yeah.
Right? So it's safe to assume that the textbook is correct most of the time. But sometimes it's not correct. And that happens. It's normal. Textbook writers are humans too. They make mistakes. Okay. So that's it for the hard questions of 9B. Now moving on to 9C. So depending on how you guys go, I may or may not go through the entire question. I may just go through the main techniques and then you guys just gotta find a way to walk through. Okay. So for example, question 9C, the first one I'll go through is question 5. Now, even though this one is supposedly simple familiar, I don't think it is. Okay. Right now for you guys, it's not simple familiar because some of them you may not know how to do. Okay, you guys remember the formula? When you antiderive ax plus b to a certain power r, where r is not equals to negative 1. What's the answer?
Ax plus b to the power of r plus 1 over r plus 1 plus c in the end.
Is that right? Is that right, Sarah?
I don't remember.
Don't remember? Almost correct. So first, you add 1 to the power, right?
Mm.
And then you divide by the new power, right?
Oh, the what's it called? You got to derive the inside of it, don't you?
No. So in this case, you need to divide by the coefficient of x as well, which is the a there. Yeah? Why? Because when you derive this, right? So if you derive something that looks like ax plus b to the power r plus 1, if you derive this, first you times the power down. So you get r plus 1, and then you derive what's inside, and then you got a, right? And then you times by the ax plus b, and then you drop the power by 1, right? But you see, there are 2 factors here. If there's nothing to cancel them out, it won't go back to just this. So that's why when you antiderive ax plus b to a certain power r, you need to have the r plus 1 and then times a at the bottom, so that when you derive it, the r plus 1 times a factors will get cancelled out, and you get back the ax plus b to the power r only without any other constants. Does it make sense?
Yeah.
Yeah? So that's the formula for that. But what happens when, what happens when the power r is equal to negative 1? For r not equals to -1, you will get this version. But when r is equals to -1, what version do we get?
It's like ln.
Yes, it is ln. Alright, so when r is not equals to -1 equals to that. When r is equals to -1, it will be equals to ln of whatever the thing in the bracket is. So ax plus b. And then?
R plus 1 to the power r plus 1? I don't know.
Not quite. Sarah, do you remember? No.
You need plus c. You do need plus.
You do need plus c, yes. You do need the plus c, the constant that we don't know, but there's something else. So remember when you derive, right? d over dx, when you derive ln x, what's the answer? Sarah, what's the answer? Should know this one.
1 over x.
Correct, 1 over x, which is x to the power minus 1, right?
You need to do the same for a.
Which is?
1 over a.
Yes, that's the idea. 1 second, but I'll show you. So when you derive, let's say ax plus ln of ax plus b, right? What's the answer? Sarah, do you remember?
Wouldn't it be 1 over the entire thing?
Yep, and then?
Plus c.
No, when you're deriving, there's no plus c. See? You're getting mixed up between antiderivatives and derivatives. When you're deriving, there's no plus c, but you need to do the chain rule. You derive what's inside as well, which is? Which gives you? A, yes. So it will be a over ax plus b, or it will be a times ax plus b to the power minus 1. We don't want the a there, okay? That's why the version to derive must have, like the answer to the antiderivative, must have the divided by a. So then you get this one, and then these two will cancel out, and then you don't have the a anymore. Okay, so what's missing here is you need to divide by the coefficient of x. Does that make sense? Sarah? Yeah? Okay, that's what we need to use in order to do these questions here. Okay, I'll move this one down here. Alright, and now let's try some of these questions. Some of these you will be able to work it out using the new rule, some will not. Do you recognize out of these 6 questions, which ones we don't need to use the new rule? The new rule is this one here, antiderive ax plus b to the power r. Which of these 6 questions do we not need to use to do that? Give you guys a hint, there are 4 of them.
A, B, F.
Correct. One more. A, B, and F, you don't need to do that. Blake, what do we do instead?
You just antiderive it normally. You split it up.
Yes, you split up the fraction. Sarah, if I were to split up the fraction for the first one, antiderive 3x plus 1 over x dx, right? How would I split this?
Just put x, like 3x over x, and then plus 1 over x.
Yes, that is correct. So then that would be antiderive of 3 plus x to the power minus 1 dx. What's the answer? Blake?
Let's do the plus 1 stuff.
No. When you antiderive a constant like 3, what do you get?
Nothing.
No, when you derive it, you get nothing. When you antiderive it though.
I've blanked.
Blank. Antiderive is when you get the derivative, right? If you get fx is 3, the derivative is 0, right? But if you get the derivative is 3, what is the original? So when you derive it, sorry?
3x.
Yes, it is 3x.
Whoa.
Yeah, so when you get 3, when you antiderive it, you get 3x. Okay? Does it make sense?
Yeah.
That's why this becomes 3x, and then when you antiderive x to the power minus 1, you get?
2x.
No. What original equation will derive to 1 over x?
Oh, you get x to the power of...
No, that's wrong already. ln of x, yes. When you get ln of x, when you derive it, you get 1 over x. So there's this one would be ln of x. And then plus c. Okay, make sense?
Yeah.
Yeah, so when we start meshing the rules together, that's when it starts getting a little bit difficult. Okay, so today I want you guys to practice on these questions here where they start meshing up all the rules together. Okay, so there's one more though. There's one more question that you don't need to use the new rule. Right? Not straight away. E? No. E turns into, E is 3 brackets x minus 1 to the power negative 3. This is exactly in the form ax plus b to the power r, where r is not negative 1. So you can use the f1 to the power, divide by the new power, divide by the coefficient of x.
well, c.
C is the same. C is x plus 1 to the power negative 2. So the answer is D. But why? Why don't you need to use the new rule? Like the ax plus b stuff for D. Why don't you really need the rule for D? The answer for that is you can use this one, right? In order to antiderive this, you can't even do it straight away because this is like, a function of x divided by a function of x. So you would actually have to expand the brackets.
X squared plus it's 2ab 2x plus 1.
Yes, very good. Sarah, do you remember this? What's the expansion of a plus b, everything squared, Sarah?
A squared plus 2ab plus b squared.
Yes, very good. Okay, Blake, what's another one? There are 3 of them, remember?
A minus b squared.
Yeah, pick the easy one.
A squared, I don't know, I can't remember if it's plus or it must be minus. Minus 2ab minus c?
No.
Minus b squared?
It's always plus b squared.
Okay.
Okay, what's the third one? Okay, I'll give you a hint. It's the difference of perfect squares. Difference, so minus of perfect squares. A perfect square is like a squared. The other perfect square is b squared. So it's a squared minus b squared, and that is equals to?
A squared.
No.
Was it a minus b, a plus b?
That's right.
Yes.
A minus b times a plus b. Okay. These are the 3 quadratic identities that are quite important. And it's good that you know it, Sarah, because in specialists you use that a lot. Okay. Anyway, so that would be x squared plus 2x plus 1 over x, and then what do? Again, we have an antiderivative, so we need to make sure to write the antiderivative. Charlie, if you're listening to this, you cannot be lazy. You have to write these symbols here, okay? It's mathematically correct. But yeah, anyway, what do we do with this expression then? X squared plus 2x plus 1 over x, how do we go ahead and antiderive it?
Add 1 to the powers.
Incorrect. Split that up. Yeah, you have to recognize that there's only 1 at the bottom and there are 3 on top, so you can chop it up here and here. Okay, so that turns into antiderivative of x squared over x plus 2x over x and then plus 1 over x dx, and then you antiderive similar to what we did for the previous question. Okay, so these ones you don't need to use the new rule straight away. You have to do some other manipulation first, but for question E, for example, alright, for question E, you will need to use the new rule straight away. So again, I would write it as, I'll start with the actual question first, alright, and x is not 1 dx. Okay, so this one would be antiderive of 3 brackets x minus 1 to the power 3 and dx. Okay, sorry, power negative 3. What's the answer using the new rule? Blake or Sarah, anyone? Remember the new rule? Add 1 to the power, divide by the new power, and divide by the coefficient of x.
3 bracket x take 1 to the power plus 1, so it's negative 2, divided by, well, it'd be 1 for the thing of a, right? And then it would be negative 2.
Yeah, That's right, plus c. Make sense, Sarah? Yeah. So once you've got that, just simplify it. So that'll be negative 3 over 2, x minus 1 to the power negative 2 plus c. Okay? And the other question will be quite similar as well. So this is question 5. That's why it's a little bit easier. Now moving on to the next one, question 6, complex familiar. Okay? I will show you guys one version and half of the other version. So when you work through it later, you gotta do both of them. All right. Given that dy over dx, so look at these two questions here. What's the difference? What do you guys think is the difference between these two questions? Try to explain in your own words.
Y equals to
Like
Sarah?
is greater than like the limit they give you.
This one?
Yeah.
Yes. So that's one thing. One is greater than 0, the other one is less than 5 over 2. Right? Why do you think that is the case? Why are the conditions different? If you're not sure, keep in mind there. I'll go through that in a second. All right. What else? What else is different between the two? And what is similar?
we get given a derivative
Yes, you're given a derivative.
and we get given a y coordinate and an x coordinate.
Yes,
Correlating.
that is correct. Okay. So the difference is this one doesn't have a constant term. Yeah. And so the one term, 2x, this one has two terms. Okay. So the technique to do them is a little bit different. I'll do them side by side so you see. Question A, dy over dx equals to 1 over 2x. And first I would write it as 1 over 2 times 1 over x. When you see a constant factor, you want to take that out, right? As a constant factor, that times into the whole function as early as you can, because that actually makes things quite a lot easier, you see. So B would be, so dy over dx would be 2 over 5 minus 2x, and to derive it, I need to convert that into this form here, negative 2x plus 5 to the power negative 1. Okay? Note that I swapped the location, because remember the formula that we learned is ax plus b power r, right? If you write it the other way around, sometimes you miss the coefficient of x. So I would rearrange it into the formula that we know. Okay, so on the left hand side, I can easily write y is equals to the antiderivative of 1/2 times 1 over x dx. And when you have a constant factor, you can just take that out, right? And take that out of the antiderivative. So you're only simply antideriving 1 over x, and 1 over x antiderive you get?
1/2 ln x.
Yeah, 1/2 ln x, very good, plus c. Okay, so that is a little bit different from this one here. I'll write y equals to antiderivative of, again, I will skip a step, take out the constant factor, and then I write the antiderivative of negative 2x plus 5, I think to the power negative 1, dx. Sarah, what's the answer?
Into 2 and the antiderivative sign, negative 2x plus 5 to the power of 0, divided by 0 times, just 0, not all times negative 2, but
Can you divide by 0?
no,
So what's wrong here?
it's the other rule, isn't it?
That's right, it's the other rule. So what should it be?
I don't remember the other rule.
When you can't derive it, it's just it's the same as when you're anti-deriving x to the power minus 1. Right? Anything that has to the power minus 1 becomes
1 over the bottom. 1 over whatever you got. Or are we doing?
it's similar. It's the same rule, just apply a bit differently.
But do you have to write it everything as ln x? Because couldn't you just?
Yes, you have to. So the answer to this would be ln of whatever this thing is.
Yeah.
Yeah? When you have a linear function of x, so Sarah, when you have a linear function of x, that ax plus b to the power minus 1, right? In this form here, to the power r, where r is exactly equals to minus 1. When you antiderive it, it will be ln of what? Of the linear function. But then you also have to divide by the coefficient of x. Okay, any question, Blake? Sarah? No? And then you got a plus c. Okay, so you see it's a little bit different. Whether you have one term or two terms at the bottom, it actually will turn out, the technique is a little bit different. Right, when you have another term at the bottom, like negative 2x plus 5 here, you have to use the linear function formula, x plus b to the power minus 1. And sometimes you may not see that as ln of the linear function straight away, but you have to learn that, because in unit 3, the only function in the function that you can antiderive is the function of a linear function. So for example, when you antiderive, so I'll put it this way, right? I'll put the f dash of x, okay? And this one is fx, okay? When you have ax plus b, so a linear function, okay, actually I'll go to the basic one first. The basic one is if x to the power a, for example, right? When you antiderive it, you add 1 to the power, you divide by the new power. Make sense? Right? Easy, right? And then when you have, yeah, this is a bit of a recap. Okay, so and then when you have x to the, or e to the power x, the antiderivative of e to the power x is, and we proceed here.
But isn't e to the power x weird, where it like stays the same?
It stays the same, yes. So the antiderivative is also the same, but you got a plus c. Right? There could have been a constant before, we didn't know. Okay, and then the next one would be sine x or cos x. When you antiderive cos x, you get?
Negative sine x?
No, just sine x plus c. Because you derive sine, you get cos. So when you antiderive cos, you just get positive sine, but with a constant, unknown constant. Does that make sense?
Yeah.
Yeah, because when you derive it, you get that, right? So when you antiderive, it's still sine x. And then how about sine x? When you antiderive sine x, what do we get?
Negative cos plus.
Now it's negative cos x plus c. Okay, so these are the main rules, and then we get to the point where how do we if it's ln x, then the antiderivative is 1 over x, and this is the trickiest part, I think, in terms of all the rules, because it's like one of them has a weird function ln x, okay, ln of x, and the other one is just 1 over x. So this is the one that most students will not recognize like in the heat of the exam, so you have to practice this one. Now I'll leave this table here. I'll do another table on this side here, and I will show you guys the equivalent but with a function of a linear function. Okay, so and then this one, a must not be equals to negative 1. So now a linear function would be ax plus b, everything to the power a. So you see, instead of just the x, now it will be a linear function, right? It could be like the one before, negative 2x plus 5. It's just a linear function, all right? So then the next one would be, equivalently, would be e to the power ax plus b, okay? And then the one after that is cos of ax plus b. And then you get sine of ax plus b. And then you get ax, so 1 over ax plus b. Okay, so these are the functions that is basically these ones here, but instead of x you get a linear function, ax plus b. Okay, so when you antiderive a function of a linear function, it's just the same rule, right? It will be adding 1 to the power a plus 1, right? No, actually I will use r here. So that'll be r plus 1 and then divide by the new power, r plus 1. But
Times by a.
sorry?
Then you need to times it by a.
Yes, times it by, you also divide by the coefficient of x. Okay, that's the only difference for when you have a linear function of a function of a linear function. Okay, any question, Blake? No, Sarah? No. So when you antiderive this one, what's the answer? Oh, and remember the plus c as well.
The same plus c.
The same plus c. E power ax plus b plus c. Alright?
I think.
Something is missing.
What? Divided by a.
Yes, you have to divide this by a. Remember, when you have function of a linear function, you always divide by the coefficient of a. Okay, whatever you do, you have to divide by coefficient of a. These ones, actually you can apply the same rule, right? But the linear function is what? If you look at that, it's 1x plus 0, right? So when you divide by the coefficient of x, it's just 1. That's why there's nothing. Okay, so these ones are actually, this linear function of x rule applies to even the basic one. It's just that is x equals 1x plus 0. Okay, so these ones here, cos becomes
sine ax plus b plus c divided by a.
yeah, note that the divide by a is only on the function. The plus c is always by itself.
Yeah.
Okay, Sarah, what's the antiderivative of this one?
Negative cos ax plus b divided by a plus c.
Plus c, that's right. How about this one, Sarah?
Ln of ax plus b divided by a plus c.
Yep, that's right. Okay, so yeah, so that's the idea. That's why we have to do the exact same thing over here, where I'll redo this step here. Alright, so antiderive that, the 2 is by itself, and then when you antiderive a linear function to the power negative 1, which is 1 over, so you get ln of the linear function, and then you have to divide by the coefficient of x, and then plus c. Okay? Yeah. Simplifying that, that would become just minus 1 of that plus c. Then we would need to find c by substituting y equals to 10 when x equals to 2, and then yada yada yada. We'll just solve for that, right? And this one would be the same thing here, sub y equals to 2 when x equals to e squared. Now, this one's a little bit different. I'll show you guys how to do this one. Sub y equals to 2, so 2 equals 2, and x is e squared. So half of ln e squared plus c. How do we do this ln e squared thing? How do we do this ln e squared thing?
Is it using the same rules?
What rule?
Is it just 1 over e squared, or doesn't
Okay.
it change?
Okay, you're calculating a number. We're not deriving or anti-deriving.
So trying to get a number for
Yeah. The answer is just a number, like 3, 4, 5, 6, 7, 8. What about?
2.7.
No. Good guess. 2.7 is the value of e, but it's not the answer to this one. How do we do log of e squared?
Oh, log e, it's 2.
Yes, it is 2.
Because it's log e, and then you move the 2 to the front.
Yep, that's right. So power to the front, 2 log base e, ln is log base e of e, right? And this thing is just equals to 1. So it'll be 2 times 1, which is 2. So then you would get 2 equals to half of 2 plus c. Any questions, Sarah? No? So this one would just be 1, and then 1 plus c, so c equals to 1. Okay, then you can just rewrite the equation, yada yada. Right? This one here, the c is just like a strange number, and then you will need to do some combination of that later afterwards. Okay, maybe I should go through this one. So y equals 10, x equals 2, so 10 equals 2, negative ln of x is 2, so negative 2 times 2 plus 5 is?
Negative 4 plus 5 is 1.
Is 1. So ln 1 plus c. What's ln 1?
Log ln 1.
What's ln 1?
E to the power something equals 1, so e 0.
0. Yes, this is just equals to 0 plus c. So 10 equals c. Okay? Anything, log base anything of 1 is 0. Because the only way for you to get 1, the power must be 0. Remember, the answer to log is always a power. Right? And e raised to what power equals 1? The answer is 0. There's only 1 power. Okay? Any last question for this one?
No.
No, it's pretty complex, familiar, right?
Yeah.
Somewhat. Okay. Let's see. 9:53. Maybe we might not be able to go through everything, but we'll just go through a few more complex familiar questions, and then might have to pause it for now.
Are we still on chapter 9c?
Yeah, so we're still on 9c. Okay, all right. Let's try this one here. I don't know why they mark this one as complex familiar. I don't think this one is. If you can do the other one, this one doesn't really feel like a complex familiar. But maybe for a new student, it might be a complex familiar. Go with that equation, passes through the point 5 plus e 10, and f dash equals to 10 over x minus 5. What are the steps to do this one?
Antiderive.
Antiderive, yes. And then?
Substitute in the points.
Yeah.
So, yeah, substitute in the point, and then you can solve for C.
So for C, yeah, that's it. Just the 2 steps. Standard, right? Not much. It's just the algebra could be a bit difficult. So I'm not going to go through that. Let's see if you guys can work through this question later. There are a few things, but I already mentioned some of the concepts previously. So let's see, when you get up to that, can you actually recall and do it yourself? Okay, next one. And this will be the last one for 9C. So maybe after this, I'll let you guys get started. So we'll do 2 chapters at a time for the complex familiar stuff. Okay, find an antiderivative for each of the following. X over x plus 1. How do we antiderive something like that? Remember how previously you can split it up because there's 1 term at the bottom. But now there's 2. Now there are 2 terms, x and 1. Which means if you were to split it, now well, you can't split, there's a top. The top has only 1 term, you can't split it. So what do you do here?
Move the x plus 1 to the top?
You can't.
Oh.
There's no product rule or quotient rule in antiderivatives. So what do we do? Okay, I'll give you guys a hint. The hint is you can split up the fraction, but you just need to be a bit creative. You can split up the fraction in a way that will cancel out the x plus 1, right? But you're just going to be a bit creative. Okay. Any idea?
No.
No? No creativity?
You can't split the terms. So you always have to have x plus 1 on the bottom.
Yeah, you can't really change that. So Sarah, the technique I'm about to show you guys is relevant to you. Some questions in Unit 4 of Specialist. You will see that next year. So this technique is something that you definitely have to learn. Okay. So okay, I'll give you guys a hint. The hint is you need to plus something and minus something. Now these 2 things are the same, right? You need to add something and minus that same thing in order to balance it out. But you add something and minus something so you can split up the fraction. What is that thing?
1.
Why 1?
Because you have the same on the top and the bottom.
Yes, that is the correct idea. It would be plus 1 and minus 1. So Blake, split that up for me. See if you have the right idea here.
X plus 1 over x plus 1 plus x take 1 over x plus 1? I don't know.
Right idea, but wrong execution. If you were to split that up, what would be the next term, Sarah?
Wouldn't it just be negative 1 over 1? Oh, is it x plus 1?
X plus 1. Remember, when you split up a fraction, the denominator is the same. Because that's how you added them, right? So when you split them up, the denominator must be the same. And how? Voila, look, x plus 1 over x plus 1 is 1. Right? Simplify. And the other one would be 1 over x plus 1. And do you guys know how to antiderive 1 over x plus 1? If it's a constant on top, if it's just 1, what's the answer?
Zero.
No, 0. Antiderive. Blake, what's the antiderivative of 1?
Oh.
It's something that when you derive it, you get 1.
X.
X, yes. And then this one becomes, Sarah?
ln of x plus 1
Yep.
divided by 1.
Yep. What's the sign in front?
Times.
Minus.
I mean, yeah.
Not times. I don't know where you get the time from. And then? This is one last thing, guys. When you antiderive, yes, plus C, you never know what the constant is. And divide by 1 is the same thing. That's why you don't need to divide by 1. Okay, but the rule applies. Make sense?
Mm-hmm.
See if you can get the right idea for question B. So we enter deriving 1 minus 2x over x plus 1. Okay. Oh, right. I haven't explained this one to you guys yet. You see how there's always like a little domain here? X is more than -1. Why do you guys think they give that domain? What causes that restriction? Like what happens when... Sorry?
Isn't it so you know which rule to use, because one of the rules is like it's equal to -1? Or something like that?
Not quite. Not in this case. Something else. Hint, look at the final answer. Is there any restriction about the final answer? An implicit restriction. Implicit means you don't say it, but it's assumed. You should assume to know that. So implicit domain, right, or the restriction for x is what? What can x not be? Is there any implicit, is there any restriction for this x here?
Yeah.
Yeah, why?
Question, but I don't know why.
No, it's assuming we haven't seen this one yet, because in many questions they won't tell you the implicit domain and you have to just deduce that and reject some answers. So looking at this final answer, right, what is the implicit domain here? Well, x has no restriction. Is that when you have y equals to x, right? Is there any restriction? No, it's just a straight line. It goes on forever. Right, there's no restriction on x. Now, is there a restriction on this one here? ln of x plus 1. Is there any restriction? There is a restriction. What is it?
It can't be 0.
Not just that. So you're saying x plus 1 can't be 0. It's not just that. It has to be strictly more than 0. Because ln of -2 does not exist. There's no answer. Okay, it's like saying log base e of -2 equals to a certain number. E raised to what number is -2? What number is this? Well, remember e to the power x, the exponential equation, is just this one. Does it ever cross through -2?
No.
No. So there's no answer. No answer for x that would give e to the power -2. So when you have log of a number, right, log base anything of a number, that number cannot be negative. So the restriction is whatever is in the ln, right, the x plus 1 here, cannot be less than or even equals to 0, right? Because that graph there never touches the x-axis, so it can't be equal to 0 either. So it's strictly positive. Okay, so x plus 1 is strictly more than 0, and you move the plus 1 over, so x is strictly more than -1, which is the implicit domain here. Does it make sense? Yeah. So when you see this domain, they're just saying that, okay, we'll put the domain in so that your answer is correct. Because Sarah, when you learn it later, there is a form where if you don't have that domain, you use the absolute symbol. So you're saying anything of x that is not that will make it negative, you absolute value that, you get positive. Have you learned that at school?
Yeah.
The absolute value? Yeah, and you will learn this one next year. Anyway, so that's why in methods they have to say this x more than -1. Okay, that's the reason for that. All right, now when we end now, that's the purpose of the explicit domain that they give there. But how do we antiderive this using the same idea as question A? It's the same idea. But you gotta be a bit creative again.
Take x plus 1, add that on.
Sorry?
Take x plus 1, add that. So do 1 take 2x, take x plus 1.
So you're saying 1 take 2x and then take x plus 1. But then
that doesn't get the same thing.
You change, yeah, it's not the same thing. What do you add and subtract in order to be able to split that up?
1.
It's wrong.
-2.
-2. Very good. So you actually take negative 2 and then you add back to y, Sarah.
You have to cancel, like, you have to get x plus 1 over x plus 1.
That's right. And how do we get x plus 1 over x plus 1 in this case? Using this?
Well, you can, I don't know.
You're so far already. You can actually get this. Got the right idea.
I thought you're supposed to cancel negative 2 out of the x, but I don't know how you do that.
You take out common factor. Did you give anyone any idea, Blake? Can you continue?
X plus 1 over x plus 1.
Okay, no. It's these two terms here. Okay, so I'll write these two terms first, and then I put the other ones, which is plus 1 plus 2 on the other side. Okay, over x plus 1 dx. Alright, plus 1 plus 2 is just 3, right? But then the minus 2x minus 2, if you take out a common factor negative 2, what's left inside is x plus 1. And the other side is just plus 3. Does it make sense?
Mm-hmm.
Yeah? And then that's over x plus 1 dx. So Sarah, this is the idea that you got the idea, but you couldn't carry through. Okay, so this is how you can actually cancel out. So when you split up in the middle, right? When you split up in the middle there, can you see that? The left hand side is just negative 2.
Mm-hmm.
Yeah? And then the right hand side is plus 3 over x plus 1 dx. So when you antiderive this, it's negative 2x plus 3 ln of x plus 1 divided by 1 is the same thing, and then plus c. Make sense?
Yes.
Yeah, Sarah? Okay? So yeah, so that's the idea. So when you see a question like that, right? What I would think in my mind is, okay, I want x plus 1, right? I want x plus 1, but right now it's negative 2x. So in order to get it, I need negative 2 in front of the x plus 1. So this is what I want. Right? This is the version I want. But in order to balance it out, you see? So if you multiply that, it would be negative 2x plus 2, right? So to balance it out, you want 1 here. So from negative 2 to 1, you need to add back 3. Does that make sense? That's another way of explaining it.
Yeah.
Yeah? Because sometimes, you may not be able to get the magic number negative 2 like Sarah did. Right? Sometimes if you don't get that, you need to start with what you want. So what you want is this version here, right? Where there's an x plus 1 on top, and you can just simply cancel it out when you split up the fraction. So you write what you want first, and then you think, okay, what sort of constant do I need in order to cancel out, in order to get back to the original constant, which is 1. Right? And so you get negative 2 times 1 is negative 2. Get back to 1, so it's like negative 2. Add what constant? Equals 1. So that constant is 3. Okay? Mm-hmm. So sometimes you might need to work out some steps on the side. It is too difficult to work through straight away.
Yeah.
So yeah, that's it. So that's all of the questions I want you guys to try out in terms of complex familiar for B and C. So maybe we won't have time for D and E, that's alright. Let's get started with these ones first. Actually, I have a list of questions here. So 9B and 9C, the ones I want you guys to do. So 9B is question 4 and 7. 9C is question 5, 6, 7, 8. Okay? Alright, get to these ones. So Sarah, you can use my notes here.